Welcome back to the lecture on radioactivity. This is part 7. Today we're looking at the continuation of simple calculations in radioactivity. We've taken 3 examples already. Let's look at number 4 example. A piece of a radioactive material contains 10 raised to the power 20 atoms. If the half-life of the material is 20 seconds, calculate the number of atoms disintegrating, decaying in the first second. That is, calculate the number of atoms disintegrating per second. Now, like I said in our previous lecture, you need to commit those formulas to memory. So here we're told to calculate the number of atoms disintegrating per second. We'll say that your decay constant is number of atoms disintegrating in the first second, that is per second, over total number of atoms present in the source. So this is what we're told to look for. We have the total number of atoms present in the source, which is 10 raised to the power 20 atoms, but we don't have decay constant. However, the examiner gave us the half-life. That is, if the half-life of the material is 20 seconds, so with that we can get our decay constant. So let's get our decay constant right away. T half is 0.693 over lambda. Therefore, lambda is 0.693 over T half. Our T half is 20. So if you resolve this, you're going to get 0.03465 per second. Now using these are major formula. Now using that, we have our decay constant now. So if you cross multiply, here we have number of atoms disintegrating in the first second will be equal to our decay constant, which is 0.03465 times the total number of atoms present in the source, which is 10 raised to the power 20. If you resolve this carefully, you will end up with this. Question number 5 now. A radioactive element has a half-life of 4 days. The fraction that has decayed in 16 days is, so we have we're not given the number of atoms, so we say let the number of atoms be n naught, and at n naught nothing actually is happening, so that will be time t naught. When we half it, don't forget we're going to 16 days. When we half it, remember that will give us half-life, and from the question we're told that our half-life is 4 days. Look at it again. The radioactive element has a half-life of 4 days. The fraction that has decayed in 16 days. So if we divide n naught by 2, that will give us t half, and t half is 4 days. If we take half of that again, that would generate 2 half-lives. And so 2 times 4, that gives us 8, since we know what our half-life is. If we half this again, that will give us n naught over 8, and that's 3 half-lives. So 3 times 4, that's 12. If we half this again, that will give us 16, and that's 4 half-lives. So 4 times 4, that will give us 16. Since we're told that the decay will take us to 16 days, we stop at 16. So fraction of the radioactive element left after 16 days is 1 over 16. Fraction of the radioactive element that decayed, will subtract 1 over 15 from 1, and if we resolve this carefully, that will give us 15 over 16. So 15 over 16 is our answer. You will take your time to study all the examples that we have done, commit all the formulas to memory, and then you will attempt these two for me. That will take us to question 6, which you will attempt for me. What time will it take a certain radioactive material with a half-life of 50 days to reduce to 1 over 32 of its original number? In other words, you're going to do it like this last example I did. Just follow up, you get your answer. Question 7. A radioisotope has a decay constant of 10 raised to the minus 7 per second. What is the half-life of the radioisotope? So you will take your time, go through all the examples, commit the formulas to memory, spend some time to memorize the formula, and then understand the examples, and then you solve these ones for me. We'll meet in part 8.